Okay, students, we're going to review for your test. Okay, you need to know all your definitions of your quadrilaterals. Okay, so I'll have you match up different definitions here. So make sure you know those ones. Number two, uh, you have a proof with a circle. Okay, here's going to be your reasons or your justifications that you can select from. Okay, so we have SSS, congruent arcs have congruent central angles. Okay, so remember that would be, if I had this, if this arc, whatever this is, say it's 50 degrees, then the central angle must be 50 degrees. Okay, so if I have multiple ones that have the same congruent arc, so I have another one, they just put hash marks on there, that means congruent arcs. That means these two angles right here, this must be then 50 as well. They have to have congruent central angles. Okay, we have CPCTC. And remember, that is only used after you prove triangles congruent. SAS, so SSS, SAS are in ASA are our ways of proving triangles congruent. And then if you need to, after that, you'd use CPCTC. The converse of that, when we have central angles, congruent central angles have congruent arcs. Okay, so this first drawing was from congruent arcs to congruent central angles. If I know I have congruent angles, central angles, so if I start with this being congruent to that, then this arc must be congruent to that arc. That's what that's saying. You start with congruent central angles, then the arcs must be congruent. Let's see. And then we know all radii are congruent. Okay, so don't forget, if I'm going from a circle, from the center of a circle, that's a radii, that's a radii, that's a radii. So that means all three of those segments are congruent. All radii are congruent. Okay. Number three, another proof with a rhombus. Okay, oops, rhombus. And then here are potential reasons or justifications to choose from. So make sure you know what these look like. Symmetric property, reflexive property, transitive property, SSS, and SAS. Okay. We're talking about knowing the definition of rhombus, but that would go along with number one, knowing the definition of all the quadrilateral properties. Or know the definition of all the quadrilaterals. But not only you have to know the definition of the rhombus, but also its properties. Okay, 5. If I have two triangles like that, A, B, C, D, E, and if they tell me segment AE and segment BD bisect each other, prove triangle ABC is congruent to triangle EDC. Okay, well, we know our last step to proof is whatever you're trying to prove. So it's going to be that, and of course, since we're trying to prove triangles congruent, it's going to be by either SAS, SSS, ASA, AAS, HL. Okay, one of the main core theorems here. Okay, now don't forget, when they go ahead and give you a vocab word, bisect, you're going to use the definition of that. So what does it mean to bisect something? Split in half. Okay, so that's going to split BD bisects AE, so that's going to bisect that one, split that in half. So I can say those two segments are congruent. And this other diagonal bisects that diagonal, so those two are congruent. And then I should see my free piece that I get there as well. And then I have enough to prove the two triangles congruent. Okay. Know which quads have diagonals that are perpendicular to each other. So not just one of them, you know, all of them. That satisfies. Next, I have a circle and two chords like that, and one of the chords goes through the center and is perpendicular. That means it's a diameter. Remember, all diameters bisect, are perpendicular bisectors of chords, so that means this has to be equal to that, and it bisects the arc as well. So they're going to then fill in information on these pieces, and you know to set them equal to each other. Obviously, whatever's here, so that was 10, and this is x minus 7. I said x minus 7 equal to 10, I get x equals 17. If I'm just making it real simple to go through it. Let's say this was x plus 2, and this is 2x minus 10. Okay, I set them equal to each other because the two arcs are congruent. And then I get x equals 12. And I might have to plug that back in to actually get the length. Okay. Number 8. I have two circles. I should remember that. If I call that A, B, and this G, H, and they give me, the given is arc AB is congruent to arc GH. I know congruent arcs have congruent chords, so then I know that chord is equal to that chord. And vice versa, if I have congruent chords, then I know the arcs are congruent. Either way, the original way or the converse. So again, they give you algebraic. So they have 6x plus 10, and here you have 3x plus 31. I'm going to set them equal each other and solve for x, but then if it asks for the length of it, I have to plug that x back in to get them. Okay. And lastly, if I have a circle and I have a point outside the circle and I draw two tangents to it, let's draw those better. Let's do it with an actual circle here. Is that my circle one? Nope. There's my circle right there. Okay. I have a circle. Let's put a point here, and now let's draw my tangent. There's one tangent. There's another tangent. Okay. Now don't forget, it's the center of the circle. Its tangent is always 90 degrees. And then since it comes from the same point, we know that those two tangent segments there. So let's say this is A, B, and C. So segment, the length of AB equals the length of AC. Those two tangent segments are congruent because they're coming from the same point outside the circle, tangent to the same circle. Okay. And lastly, okay, A, B, C, D, and E, and just making up letters here. They want to prove these two triangles are congruent. Okay, let's say they give you that AC is congruent to EC. And now they ask why the two triangles are congruent. You should know now you've only got two pieces given to you, the right angle and that segment. Those segments are congruent. That means I must be able to come up with one free piece on my own, and then be able to say why those two triangles are congruent. Okay, so make sure you're naming the sides that are congruent and why they're congruent. What's the justification for it? Whether it's given, whether it's one of the free pieces. Remember your three free pieces are reflexive property, vertical angle theorem, and AIA if you have parallel lines cut by a transversal. Okay, so that's a summary of what's on your test. So make sure that you know those. You can make up your own numbers, equations for them, and practice that, and that'll do it.